Okay, this is 11.8, the binomial theorem, day 1. So kind of still talking about patterns, but very different at the same time of what we were talking about before. So we're going to take 2 days on this binomial theorem. It says on top, observe some of the patterns that appear when a plus b to the n is expanded, if n is 0, 1, 2, 3, and 4, and so on. So basically what we're talking about here, and the first one's kind of goofy to think about, but to the second power means that there's two of them. So this is like we have a plus b times a plus b. And we have two binomials, so we know that we FOIL in order to solve this. Basically, this is what are you going to get? Okay, and we're just writing it out in expanded form. Okay, so first of all, let's write this down, and then we're going to talk about some of the patterns that we see. Now, if you expand out a plus b to the 0 power, anything to the 0 power is 1. That means that both of your variables in here, a and b, are raised to the 0 power. Because again, anything to the 0 power is 1. This whole thing just equals 1. Okay, now here, we're going to have 1, a to the first power, b to the 0 power, plus 1 a to the first, or 0 power, and b to the first power. Again, this is not going to make much sense until we talk about some of the patterns that we're going to see. Next line, I want you to write 1a squared, b to the 0, because b will not be there at all, plus 2a1 b1, because remember we always combine our middles when we FOIL. This one's the easier one to think about than all the other ones. Plus 1a to the 0 b squared. And again, anything to the 0 just kind of means it's not there. But we're going to write it in there because we want to see the pattern. Next line down, we have 1a to the third b to the 0 plus 3a squared b to the first plus 3a to the first b squared plus 1a to the 0 b to the third. And the last line that we're going to do, and we actually could keep going on with this pattern, but we're going to stop here, and then we're going to talk about what we see. 1a to the fourth b to the 0 plus 4a to the third b to the first plus 6a squared b squared plus 4a to the first b to the third plus 1a to the 0 b to the fourth. Okay, so now just taking a look. Do you see any patterns? How did I come up with all of these numbers and these letters and whatnot? Well, first pattern that I see is n is the exponent of a in the first term, and it's the exponent of b in the last term. So what I mean by that, this n right here, this is our n here on each of these. Here's 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Or you can look at it on the opposite side of the triangle. 0, 1, 2, 3, 4. So that's what I mean by n is the exponent of a in the first term and b in the last term. Now what happens in between that? Well, the exponent of a decreases by 1. It starts with n and it ends with 0. So it starts with the n. So on this last one, for example, you can see it really well. 4, 3, 2, 1, 0. And then in the opposite, the exponent of b increases by 1. It starts with 0, and then it ends with the n. Very interesting. Oh, starts with 0 and ends with n, this is supposed to say. Cross that out quick. If I'm going too fast for you, remember, just go ahead and pause and write these down. The sum of the exponents in each term is n, which is very interesting. So example, this one, our n is 3. If you add up the exponents, they always equal 3 on each term. And last one, it says coefficients are symmetric. They increase at the beginning and then decrease at the end. So we're talking specifically about these numbers that are found in front of the variables. Notice they're symmetric, meaning they're the same on both sides. Here's our middle 6, And then we have 4s on the outsides of those, and then 1s on the outsides of those. They are perfectly symmetric. Now the next part, we're actually going to talk about those coefficients, and they actually stand for something. They are a part of Pascal's triangle. The coefficients, in other words, the numbers found in front of the variables, of what we did above by expanding out those binomials forms a pattern often displayed in a triangle, specifically called Pascal's triangle. And we're going to make that triangle right down here. So we are going to write down just the coefficients that you see from above. Just the coefficients. So basically taking away the plus signs, taking away the variables. So on the first line, a plus b to the 0, all we see is a 1. And we're going to write that 1 right in the middle of our triangle. The second line, I see a 1 here and a 1 here. We're going to kind of lopside that out because remember we're making this in the shape of a triangle, kind of like how you see it above. A plus b a plus b squared, you see a 1, a 2, and a 1. A 1, a 2 in the middle, and a 1. Next line down, 1, 3, 3, 1. 1, 3, 3, 1. And the last line that we did above, we have 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Now, what do you see with just the numbers? How do we get from the one line to the next? Can we? Well, what I see here, kind of like Fibonacci, 1 plus 1 makes 2. 2 and 1 make 3. 2 again, 1 again, make 3. Here in the middle, 3 and 3 add together, make 6. 3 and 1 makes 4. 3 and 1 here makes 4. Very interesting. So we're basically adding, and there's just 1s on the outside. So if we try to do the last one without having any knowledge of what it is above, we have 1s on the outside. What would be here in the middle of 1 and 4? Well, 1 plus 4 is 5. What would be here in the middle of 4 and 6? Well, 4 plus 6 is 10. Here, 6 plus 4 again is 10. And here, 4 plus 1 is 5. So notice the even numbered rows, like these 3 here, like the last one we just did, aren't going to have a middle number. 10 and 10. But the odd numbered rows, like these two, are going to have have a middle number that is not the same as the ones on the outside. So very interesting. Now, using the pattern in Pascal's triangle, we're going to write this next one in expanded form without even having to FOIL that many things in it. So, very cool. Let's try this out. Now, if we expanded this, let's just expand it by one more line down because we do need to know what the triangle is for the 6th power right here. Let's go ahead and fill this out. So, 1's on the outside. And then let's add. 1 and 5 makes 6. 5 and 10 makes 15. 10 and 10 is going to have 20 in the middle. 10 and 5 is 15. And 5 and 1 makes 6. So now, using the pattern in Pascal's triangle, let's write this out in expanded form. So all we're going to do is we're going to take our x plus y to the 6th power, and we're going to start by writing this out. So, first number, 1. First variable is an x, and we're going to start that first variable out with a 6. Remember, we're just doing exactly what we did up here. We're taking that first variable, we're starting with the n, and we're going to count down. And our second variable, we're going to count up the whole way through. And then everything's going to have a plus sign in the middle. So I have y to the 0 plus, next number, 6, x to the 5th, y to the 1st, because remember you're counting up, counting down, counting up. Next number, 15 in the triangle. I have x to the 4th, and I have y to the 2nd. Remember, these two numbers always add up to whatever your n is. In this case, it is a 6, remember. plus 20 x to the third y to the third plus 15 x squared y to the fourth. Always double check on what you're counting down by and what you're counting up by, remember. Plus 6x to the first y to the fifth. And the last one, 1x to the 0 y to the sixth. Just double check, and this gets me every time. All of a sudden I'll hit the middle, x to the third, and I'll start counting up again on the x's when I'm supposed to be counting down. So just check. My x's started at 6, they ended at 0. My y's started at 0, they ended at 6. It looks good to me. Now the last thing we are going to do is we're going to clean this up a bit, because remember we said that anything to the 0 power is really not there. We don't need it in the problem. So we're kind of basically just taking away all of those, anything with the 0 power. And remember, we don't need this 1 in front of here either. So 1x to the 6 times y to the 0, all that really matters is this x to the 6th. So I'm just going to write that down. Okay, cleaning up our problem. Here I have 6x to the 5th, and then y to the 1st. Usually you don't see that first power there, so I'm going to clean that up and take that away as well. 15x to the 4th, y squared, just repeating that. Repeating the next couple actually. Whoops, I forgot my x. X to the 3rd, y to the 3rd, plus 15x squared, y to the 4th, plus 6x, again, we don't need to put the first power, not needed, y to the 5th, and then cleaning up my last term, remember x to the 0 is basically not there, it's just y to the 6th. Now, if this is a step that you can do right away as you are writing out this, more power to you. That's fine. You don't have to do this step first. I do want to see these answers cleaned up, though. I want to see this step. And that's our answer. Let's check out another one. A little bit tougher, mainly because we have numbers in front of the variable that we're actually going to have to multiply through as well. Okay, so now, third power. First thing I'm going to do is I'm just going to write down the coefficients that went along from Pascal's triangle for the third third tier of the triangle. So it was 1, 3, 3, and 1. And then we're going to add in the variables next. So if I'm expanding out 3r minus 2s to the third power, my first coefficient's a 1. I'm going to take my first variable, which is actually not just an r anymore. We're actually going to take that 3 along with it. So 3r, notice I'm putting it in parentheses because we're going to keep it together, raised to the n, which is my third power, times, now, instead of writing just 2s, I'm actually going to write a negative as well. So negative 2s to the 0 power. So we're going to kind of treat that as a negative sign, plus a negative sign. Plus, so always plus signs in between here, 3, which is my next coefficient, my 3r, my next variable. So remember, think of this as your a and this is your b when you're expanding this out. 3r to the second, because I'm counting down on those exponents, negative 2s to the first, because I'm counting up on those exponents. Next coefficient's a 3 again, 3r to the first, and then negative 2s to the second, and last one is a 1, 3r to the 0, and negative 2s to the third. Now this one we do need to do some cleaning up for sure on. So first thing I'm going to do is I'm going to expand everything with a variable, or the exponent on it. So I have 1 times 3r to the cube means that 3 is cubed and r is cubed. So 3 cubed is actually going to give me 27. R cubed is just r cubed. And then remember, anything to the 0 power, cross it out, it doesn't matter. 3r squared, so that means 3 is squared, which is 9. Negative 2 to the first power is just a negative 2s, nothing's going to happen with that. 3r to the first, just going to stay a 3r. Negative 2 squared, now that means negative 2 times negative 2, which is actually a positive 4, and then s squared, plus 1, and then again 3 to anything to the 0 power, just cross it off, don't have to worry about it. Negative 2 to the third power is a negative 2 times negative 2 times negative 2 is going to give me a negative 8 s cubed. Okay, simplify one more step. 1 times 27r cubed is just 27r cubed. Now because there is a negative sign in here, I'm going to go through and multiply my numbers together first. 3 times 9 times negative 2. 3 times 9 gives me 27. 27 times negative 2 is going to be a negative 54. So I'm going to write minus 54 r. I have 2 r's and 1 s. Plus 3 times 3 is 9. 9 times 4 is going to give me 36. There's 1 r and there's 2 s's. And 1 times negative 8 is a negative 8. And there's s cubed. So take care of the numbers first and then kind of just throw the variables in there. And there is my simplified answer. Now, could you have taken 3r minus 2s times 3r minus 2s times 3r minus 2s and FOILed all that together? Yes. Would you have gotten the same answer? Yes. Again, this is just a different version using the binomial theorem. Okay? I'm not quite sure why I have this extra box in here, so don't worry about that. Now, it says use the binomial theorem to write a minus b to the 7th in expanded form. We're going to do the same thing, but this time we need the 7th tier of our Pascal's triangle, so let's write that down first. So basically, I'm looking at the other side of your note sheet, and I'm going one more triangle down, or one more layer down. So I'm going to have 1, 7, 21, 35, 35, 21, 7, and 1. Okay, so let's add in some numbers here. So I'm doing a minus b to the 7th power. First coefficient is a 1. First variable is an a. Started off at the 7th power. Now because this is a minus sign in the middle, remember we're going to do a negative b to the 0 power. Plus 7. That's my next coefficient. A to the 6th. Oops, I'm not quite sure why I'm putting parentheses around that. No need for parentheses unless there's a negative in there, right? Negative b to the 1st. Plus 21. A to the 5th. Negative b to the 2nd. Plus 35. A to the 4th. Negative b to the 3rd. Plus 35. A to the 3rd. Negative b to the 4th. Just remember which ones you're counting up on, which ones you're counting down on. Biggest thing to remember. 21, a to the 2nd, negative b to the 5th, plus 7, a to the 1st, negative b to the 6th, plus last one, 1, a to the 0, negative b to the 7th. Okay? Last step, let's clean this up a little bit. I'm going to cross out anything with a 0 in it because I don't need to worry about it. Here I just have a to the 7th. Now, because I have a negative b here, it's like we have a negative 1. So 7 times a negative 1 is going to give me a negative 7. I have 6 a's and I have 1 b plus, again, negative 1 squared is just going to give me a positive 1. So positive 1 times 21 is 21. I have 5 a's and 2 b's minus, because you're going to notice that these signs are actually just switching around, 35, a to the 4th, b to the 3rd, plus 35, a to the 3rd, b to the 4th, minus, notice I'm not even paying attention to those negative b's anymore because I already see the pattern. I'm going negative plus, negative plus, negative plus, 21a squared, b to the 5th, plus 7ab to the 6th, minus, oh, I almost fit it on one line, b to the 7th. And there is my answer on that one. One more thing I'm going to introduce you to in this section, and then we're going to talk more about it tomorrow, is actually a pretty easy concept, factorials. The symbol for factorial is actually an exclamation point. An example of a factorial is, for example, lots of times you're going to see a number with an exponent after it, just like the example on the bottom. That just reads 9 factorial equals, and all we're going to do is we're going to start with the 9 and we're going to multiply by all of the numbers that come after it if we count down all the way until 1. 9 factorial is basically this, just in expanded form. It's just a lot simpler to write 9 factorial instead of 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? Now, let's go ahead and evaluate. To evaluate these, where I'm actually going to show you a very cool, slick trick in order to do these. Lots of people try to do this in your calculator. What happens is you're going to get an error sometimes because it's just too much for your calculator to do almost. So what we're going to do is we're going to expand each of these out first. So 6, 5, 4, 3, 2, 1. So using the definition of factorial, let's expand each of these numbers out. On the bottom I have 4 factorial, which is 4, 3, 2, 1. And 5 factorial, which is 5, 4, 3, 2, 1. Now, remember, if anything's on top and the exact same thing's on the bottom, you can cancel things out. So like this one cancels with the 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5. Now anything else we can cancel? Well, I know 3 goes into 9 3 times, so I can make that smaller. 4 goes into 8 twice. 2 goes into 6 3 times. And look at that. We only have 1s on the bottom. So we don't even have to worry about the bottom anymore. On top we have 3 times 2 times 7 times 3. And that will give us our answer. And that's actually going to give you end up with an answer of 126. So that's just kind of something to put in your mind for the next section of notes.